A question came up on Discord this week about deep compositing in VFX. Let's look at some tips and best practices for the current state of play. I'm Jeremy Hardin, and this is Open Dailies. Today, specifically, we're going to do some training rather than reviews, as I mentioned with our question on Discord. So I think to discuss deep compositing, for those that are not familiar, there's a really good article on Effects Guide that covers the history of deep compositing. Particularly of interest, and is good to understand the technology because it helps us refine the workflow now, is deep shadow maps and Pixar's RenderMan as part of this discussion. So knowing this and knowing the technology of how it's stepping through space relative to a source, originally a light or a camera placed at a light, and now actually from the camera, helps us understand the best way to work with this now. So I do recommend this guide. So what we did is we did a test where we generated some volumes quickly in Embergen and tried to take it all the way through the pipeline using our existing off-the-shelf tool. So our pipeline is already working again for the EXR side of things. So can we use off-the-shelf tools to get a deep shot through the pipeline? What I'll do is I'll break down our process so that anyone who wants to repeat this process to familiarize themselves with deep may do so. And then I'll share our findings and conclusions. So to generate the volumes, we used Embergen, which I'll jump to now, and I'll just hit play. So when you open Embergen, the current release of Embergen, you are greeted with a preset, which is very nice, and this is all working on the GPU on our local workstation. So this is not using our cloud workstation. So local Embergen running here. One of the good things about Embergen is it comes with a significant number of presets, and I do recommend checking it out just based on that because it gives you some good starting points for a lot of different types of effects. So we went with Rubble shockwave. And I'll let that play. And I'll just restart that so we can see it happen again. So, some nice evolution within that. We then went to the simulation, upscaled it. So, like so, just to get some nice detail in, apply a new resolution. And then we created a VDB export and connected that to our simulation. In our export, we wanted to make sure that density and specifically velocity were preserved. And then we're in Maya, so we wanted to go Y up right-handed. Generally, Houdini workflows tend to center around one Houdini unit is 1 meter. So in case we took this via Houdini, and in keeping with fluid workflows, we went ahead and set this to meters and then exported. So I won't do that now because we've already exported. We exported 50 frames, which took, I think, about 5 minutes on Embergen. So that was very useful. Once we got it out of Embergen, we took these renders into Arnold. So I'll go back to our contact sheet. And this will get into our best practices. Looking at the top left, where we're discussing tolerances. These are the default tolerances for alpha, depth, and beauty. And we can see the file size was 1 gigabyte per frame. The other thing to consider is Arnold is a great renderer, and depending on your hardware, it can be quick. But for we're working on a local workstation, which I was doing for this test, time to iterate and do these tests can be prohibitive. So straight away, we're into a scenario where we thought, let's try Redshift. To my knowledge, this is a new feature within the Redshift renderer DeepEXR support. And straight away, we can see, if we look at the torso of our mannequin, we're seeing artifacts where the smoke intersect the body. Exploration of forums and support have revealed that volumes are a limited feature set right now within deep rendering in Redshift, where most renderers we're specifying how many samples by specifying the tolerance. When Redshift would hit currently at the time of this video, when Redshift deep rendering hits a volume, 2 samples are supported, which means that, some of the benefit of deep rendering and deep compositing are lost if using Redshift for volumes in this workflow. So that took us back to Arnold. With Open Dailies, we support compositing applications that might be available to different users. So we use Nuke in-house, but Natron and Fusion, as well as After Effects, all of these compositing applications are referenced with questions. So we did check, and at the time of this video, there's no compositing application other than Nuke that supports deep compositing. So we looked at Blender as well, because Blender has some functionality. So I think that obviously makes it difficult for people to check the files that they're producing if they don't have access to Nuke. So that's something to bear in mind. So we've got our full workflow now with volumes in Embergen, VDB into Maya, rendered in Arnold as DeepEXR. And then the question that comes up straight away is what settings? In our experience, the reason that it's difficult to answer the what settings question is because the settings themselves, if we look at these tolerances, these are spatial tolerances. So these are talking about the difference in 3-dimensional space within our 3D scene. In this case, our scene is a mannequin standing on a floor with a 1 meter cube and a volume. So the settings then for this are going to be very different than a volcano erupting or something at Ant-Man scale, with it at the micro scale. So then what that means is there's not a preset that will just work for everything. As a result, that actually leads very well into good best practice in general for deep. We've run into the same things with hair and fur as we move from one renderer to another. The ideal scenario for finding the right values is wedges. The order that we do those is first we do ground truth frames. So if I go back to our contact sheet, the upper left, we notice that is not moving. That is not moving because at 1.2 gigabytes per frame, our ground truth image is good for sanity checking against in the future, but is prohibitive to maintain that disk space and render time all the way through the workflow. So this is our workflow. Start with the ground truth image, ideally a still, or if we have the latitude, a first, middle, last frame workflow. Consistency is going to be important. So whatever we do for that first, we're going to carry that single frame or those first, middle, last into our wedges. So there's a temptation to start at max settings and work backward. There's a temptation to start at minimum settings and work forward. This is the trade-off that works best in our experience, in my experience, which is start with the ground truth, the one that most simulates reality without the technical limitations. Then having that as our watermark, our waterline for how things should work, we then apply all of the technical limitations. We put settings to the lowest. We use, in this case, we jump to Redshift. We use the fastest renderer we've got. We try to get the file size as small as it can be, rendering as quickly as it can, and see what breaks. So we wouldn't know what's breaking and why without our ground truth image. But at the same time, it means we don't work backward from our ground truth image and end up with a file size that's too large and takes too long to render. I'm sure many people working at facilities will have the experience of being told, we've had to tell people, your renders are taking too long. your renders are too large. There can be a challenge at that point to troubleshoot. So using this workflow can be really great for having material already ready when those conversations come up. So that's not to say that the conversations won't come up. I'm sure that someone will come around and say that we're using too much disk space or the renders are taking too long. Those can be informed discussions as a result of this. When I mentioned wedges, we can see that I've got four renders here, and we could very easily do more. So good best practice time-wise is to launch these at once. So know what we're wedging. We can see that I've changed the alpha, depth, and beauty tolerance. So launching these wedges, poor usage of our time is launching a render, a local render, waiting. Better usage of our time is launching a farm render wedge with different settings, moving on to another task. And if we're rendering locally, then obviously we might have to Houdini allows chaining of ROPs so that we could launch these in succession overnight, as an example, or in the case of Maya using render layers to be able to launch multiple renders. So the wedge is a great tool for disconnecting artist time from machine time. The last thing I'll say workflow-wise is the power of the Deeprecolor workflow. So I'll just quickly jump to nuke. We've got a deep to points of our bottom right render on the contact sheet. So as we go to the contact sheet, bottom right is what we're seeing in nuke. The Deeprecolor allows us to separate, this note here, allows us to separate the beauty element from how it will be layered. The value of that is our beauty element. If we're looking at this smoke, and rather than having one light, I've got 20 lights with AOVs. Not only is the iteration slow if we have full fidelity lighting in the deep render, so not only is the render slow, but being able to manipulate that the lighting information is best done in a sort of reconstructed subtractive compositing 2D way. In other words, we already need to be in 2D space when we start working with AOVs. So it's much better to have a beauty render with all of our lighting AOVs or secondary displays, depending on how you want to call them, and then to have the depth information unless there's something that can't be done with that. What I think also makes sense is to talk around some of the settings that are consistent across the deep workflows from the things that we tried. And look at our Arnold render settings. They've got some great documentation here. What I want to highlight is the consistent principles between this Redshift, once that comes up to volume functionality, and mantra, which we also use. So tolerance is a consistent notion, a consistent principle, where in 3D space, if the samples are closer together than this value, then they will be merged and you will have less samples. So a larger tolerance is going to merge spatially more samples. Arnold specifically calls this tolerance. So again, let's jump back to Chrome. We can see that we've got different tolerances for alpha, depth, beauty. Adding AOVs in Arnold will also give you different tolerances per AOV. As we jump to mantra, looking on the mantra settings, it will be the DCM Z bias. DCM is from the history of deep compositing, where the deep files were essentially the same workflow as shadow maps, so deep camera maps. So DCM Z bias will functionally act the same or serve the same function as tolerance in Arnold. And as we go to our Redshift documentation, we have options for merging samples. Specifically, the mode would be Z mode, so not object ID mode, which is a different Redshift specific option, but there's a Z threshold, deep merge Z threshold, which is comparable. But understanding how these work actually means that the knowledge we have in one amortizes and crosses to the other. I think let's talk about strengths of deep, known weaknesses of deep, and another weakness that I think is not really as much known. Let's jump back to nuke. The strengths of deep. Let's just drop down a deep merge. We're going to utilize a holdout mode. So by default, deep merge is a combine that leaves both visible. If I go to operation holdout, we can see that A is holding out B. So this is giving us an image very much like a non-deep workflow where we render one object as matte in order to have two separate renders, and we composite those. The issue that we run into with a traditional non-deep workflow comes in with sort of motion blur and more complex layering, particularly with bright objects behind or in front. There was a shot on Geostorm that probably could have benefited from it. We had some very long render times. We had to keep splitting out layers of volumetrics, rigid body destruction, and beauty elements. And what we get into whenever there is we start to get edge issues in a holdout, the non-deep solution is to render a volume layer with and without holdouts so that a compositor can patch. So can look at where the holdout is not working, or we're getting fringing or something along those lines, and to patch. So counterintuitively, we may end up rendering volumes in a holdout workflow multiple times to be able to composite those. That means that we could be doubling our disk space for volumes in a non-deep workflow just in order to have the ability to composite effectively. So that can be a bit of a trade-off where we find ourselves using a lot more disk space than we set out, trying to avoid deep. So fast camera motion, high contrast between layering of dark and light. So night shots with explosions happening in a large scene, spatially large scene, rendered out as layers gets complex. And if we have 10 volumes in that layer and they're all rendered with and without holdouts, that's straight away 20 beauty renders, which becomes a bit of a problem. So deep at its strongest makes those problems go away. Because the holdouts are happening, as we can see in Nuke, the holdouts are happening right in the composite itself. This is a slower compositing workflow, I would say, because of it's harder to scrub the timeline when you're working with deep data. So you do end up sort of pre-comping this into layers. If for some reason an issue does come up, you're already in comp. So it's not going back to lighting, going back to another department. That's a huge strength with deep compositing. The commonly known weaknesses are, disk space. Be sure you've got a large server to be able to hold it for the duration of the project. I think that's a valid criticism, but the less intuitive downside of a deep workflow is exactly what we're seeing in the process of, if we do a lighting render and it doesn't look like the reference, it's time to do another version. So there's a visual feedback component to creating a simulation that's meant to look like a real explosion, or lighting that's meant to look like real lighting. We can gather a reference for whatever we're creating in CGI or in VFX. Finding the right settings is impossible to find the reference. So it's all down to workflow of not doing a local render at one setting, waiting hours, checking file size, and then not moving the project forward and not getting beautiful images in front of the client. So in conclusion, workflow is important. Deeprecolor is a strong default, and consider that one of the challenges that is not as well known for deep is finding the right settings, and consider that part of the creative process. So hopefully that is helpful as a discussion of the current state of off-the-shelf tools and deep EXRs and deep compositing. Thanks for watching. Be sure to subscribe here for more VFX training and open dailies. If you'd like to join the conversation, our Discord is invite only, so feel free to reach out at our website, www.darkcosmoscreative.com. Thanks very much.